Welcome everyone to the Physical Verification Thought Leadership Podcast. I'm Srinivas. I'm the Product Management Director for IC Validator at Synopsys. With me today, I have Changi from Cerebras. Changi, would you go ahead and introduce yourself and tell us a bit about what you do and what does Cerebras do?
Sure. Hello, everyone. My name is Changi. I'm a member in the physical design team in Cerebras Systems. My primary responsibility is top-level integration and sign-off, and that includes place and route, physical design verification, EMIR, and ESD checkings. On top of that, I also contribute to the flow development for those areas. At Cerebras, we design and build systems that's specific for AI purposes. And the engine of our system is an AI accelerator, which we call wafer scale engines. The wafer scale engine is essentially a 12-inch wafer without dicing. And so far, we have taped out 3 generations of wafer scale engine.
Hey Chengdi, what are the challenges that you are facing currently with physical verification?
As we move to more advanced nodes, we notice that the device dimension shrink, which means the number of transistors increase. And besides, for back-end of line, meaning for metal interconnect, we see increased numbers of metal layer from 13, 15, 17, and even 19. We also observe there are increased number of DRC rule counts from N16 to up to N3. I think there's at least a twofold increase. And so combined with the more rules in the wrong set and more transistor, more wires and VS to check, we see increased runtime and compute resource required as we move to advanced node, and that's number one. And with these more complicated rules and hierarchy interactions, what comes after is a longer turnaround time to fix these violations, as well as after we fix this violation, we have to go back to implement them either in the block level or chip level, and then reanalyze. So it's a much longer time to debug and fix. And third, if we consider per analysis for ESD as part of PDB, the per analysis will require equal, if not much more runtime than the traditional LBS DRC analysis. And so these are what I think the biggest challenge currently facing PDB.
Thank you for that, Chengdi.
Sure.
Can you tell me about a complex project that you have managed for physical verification, and what strategies did you employ to navigate these complexities and achieve success?
Sure. As I mentioned earlier, at Cerebras, we have successfully taped out 3 generations of wafer scale engine that's designed to handle AI workloads. Being a wafer scale engine means that we have to make sure it's PDB clean at that level. And for that kind of challenging project, we have to start from implementation early on. So we partition the design with the speed and runtime in mind, such that the runtime is acceptable during the final integration phase. But what's more important is during the PDB verification and analysis, we took a few approaches to make it feasible. First, we use the scaling and electric CPU that's provided by the ICV tool so that we can get the amount of right resource that we need. And secondly, we also divide and conquer the design, whether it's in hierarchical fashion or we split the run set into rule groups. We also use extensive ICV black box capability to run parallel analysis at block level and chip levels. And lastly, we also try to catch the potential issue early by running key PDB rule check.
Yeah, thank you for that. Definitely the strategy of dividing and conquering your physical verification runs, and then the close collaboration between Cerebras and Synopsys. I think that definitely helps it helps you deal with the physical verification
I
challenges.
can disagree more about that. One thing that's very key is that we always engage with our tool vendor from very early on. And so we get the latest updates and improvement from each binary release. And we also get great support when we run into some of the unavoidable issues during the final phase of PDB work.
According to you, what are the critical skills or knowledge areas that future leaders in physical verification need to develop to be successful with physical verification?
Sure. I think for PD pressure on owner that's getting into a PDB job, and so these people, their primary job is to code the design, but they need to use ICD to validate their work. For these people, I think it's very important that they know the tool very well and know the run set well. And getting familiar with the run set function will just go a long way to help them fix the violation, whether it's LBS antenna or DRC. On the other hand, for PDB folks whose primary focus is in PERC and ESD, I think it's important to understand the ESD fundamentals. And that way they can tell which ESD rules are very important and what type of ESD violation are severe. And lastly, for PDB specialists whose primary function is to develop run set and flow, I think it's important to keep up with the process feature, the new FinFET, the new middle end of the line, interconnect, the new hybrid row and FinFlex flows, as well as the new backside powering. Knowing this fundamental will help them to develop better flows.
Yeah, no, I completely agree. Being very well aware of the process nodes, what are the new technologies, new checks in the process, what are the fundamentals for ESD, and essentially knowing the run sets for your physical verification, so you clearly know what are the rules you're trying to debug, are really critical, which will help you be a good physical verification engineer. Thank you for the time, Changi. Really appreciate you collaborating with Synopsys on this physical verification thought leadership podcast. I look forward to continuing the close collaboration between Synopsys and Cerebras. Thank you again for your time.
Sure, thank you. I'm glad to be here today, and I really appreciate the great support that Synopsys gave us over the years.
All right. Thank you, Changi. Have a good day.
Bye-bye.